Good morning, student. Today we are going to learn about design language and VHDL. After the completion of today's session, you are able to discuss the design languages, define EDA tools, and understand VHDL. So, first we discuss about the design language. Design languages are of two types. First one is software programming languages, in short SPL, and hardware description languages, in short we can say HDL. At one time, designers were either software or hardware designers, and design teams were clearly distinguished by these separate roles. Today, however, designers are involved in both software and hardware design and need skills in both the areas. So, software programming languages (SPLs) allow a software designer to create executable software applications that will operate on a suitable processor. The target processor will be one of three types, that is microprocessor, microcontroller, or digital signal processor. Then hardware description language is a specialized computer language used to describe the structure and behavior of electronic circuits, and most commonly digital logic circuits. A hardware description language enables a precise formal description of an electronic circuit that allows for the automated analysis and simulation of an electronic circuit. EDA tools. EDA stands for Electronic Design Automation. It is a category of software tools for designing electronic systems such as printed circuit board, that is PCB, and integrated circuit, that is ICs. The tools work together in a design flow that chip designers use to design and analyze entire semiconductor chips. EDA is also referred to as Electronic Computer Aided Design (ECAD). Some of the EDA tools are Cadence, Synopsys, Mentor Graphics, Xilinx, Electric, Silvaco, Glade, Alliance, etc. Some of these tools are open source and available for free, and some are licensed based, for which we have to pay. So in the industrial environment, Cadence, Synopsys, and Mentor Graphics are mostly used. To use these softwares, we have to purchase the license as they are not open source. But for learning purposes, we can use open source software tools like Electric, Alliance, Glade, etc. We don't need to pay for them. We can download them for free of cost and use it. So next is the VHDL. So VHDL stands for Very High Speed Integrated Circuits Hardware Description Language. So in short, VHSIC, Hardware Description Language. Okay. It is a hardware description language, means it describes the behavior of a digital circuit, and also it can be used to implement a digital circuit hardware. It can be used for digital circuit synthesis as well as simulation. It is used to build digital system using programmable logic device like CPLD and FPGA. VHDL program is used to implement digital circuit inside CPLD or FPGA, or it can be used to fabricate application specific integrated circuit. So let's discuss about the VHDL program structure. All the VHDL program consist of at least two components, that is entity and architecture. It may have additional components like configuration, package declaration, body, etc. as per the requirement. So let's take an example. And in every program, library declaration is a must, which is declared in the beginning of the program. So this one is the first part of the VHDL program. This one is the library declaration. The library contains all the piece of code that is used frequently. It will allow us to reuse them again and again. Also, this can be shared with other designs. It starts with keyword library followed by library name. Okay, so keyword library followed by the library name. There are three libraries usually used in all VHDL codes, that is IEEE, STD and work. So IEEE specifies multi-level logic system. STD is the resource library for VHDL design environment, and work used for saving our project work and program file. But in program code, we need to declare only the IEEE library, because the other two libraries are default libraries. To add library packages and its part, USC, this one, use keyword is used with library name, library package and package parts. In the IEEE library, the package is std logic, means std underscore logic underscore 1164, and to add all its part we can write this. Okay, next is the entity declaration. Entity defines input output connections of the digital circuit with which it can interact with other circuit. So it declares the number of inputs given to the circuit and the number of outputs taken out from the circuit. So here XY is the inputs and sum and carry are the outputs. Also, it declares any intermediate signals that are used within the circuit. Entity declaration starts with the keyword entity. The user has to give desired name to entity. Here it is given adder. Inside entity, input output pins of a circuit are declared using keyword port. The entity declaration ends with keyword end, this one, followed by entity name, that is adder. Okay, so this one is the entity declaration. Last, architecture. Architecture declares the functionality of the digital circuit. It gives internal details of an entity. That means how input output are interconnected. The architectural declaration starts with keyword architecture, this one the keyword, followed by the architecture name and entity name. Architecture name, here it is behavioral, and entity name is adder. The begin keyword indicates the starting of the architecture body. This one is the starting of the architecture body. The architecture body ends with keyword end, this one keyword end followed by the architecture name, that is behavioral, and within this architecture the functionalities of the digital circuit declared. So this is all about VHDL. Thank you.